Hello to all students. In continuing the chapter number 3, that is the transmission line parameters, in which the first section is the calculate the resistance of the transmission line. So today, the resistance of any conductor, this is the basic term that in the previous classes we already covered. The resistance of any conductor that the transmission line can be determined or you can that can be calculated by the equation 1.1, that is the R is equal to rho L upon A. So where R is the resistance and the rho is the resistivity of the conductor of, you can see that the resistivity of the wire, and the unit of the resistivity is the ohm meter, and the L is the length of the wire that can be measured in meter, and the A is the area, cross sectional area, that can be measured in meter square. So this is the basic formula of the calculation, how to calculate the resistance of any wire of any conductor, that is R is equal rho L upon A. So when we talk about the resistance of the transmission line, so here this is the major point, that when the alternating current flowing through the conductor, the current density is not uniform over the cross-sectional area, cross-sectional, but is somewhat higher at the surface. This is called the skin effect. Make in mind always that when we talk about the alternating current, there is a, in the transmission line, there is a major effect that can be produced, that is the skin effect. When the AC current is flowing, the skin effect will be produced. And what is the this effect? This effect is that the current density is not be uniform over the cross sectional. This term is not be described here in detail, but this is the some concept here, that this is not current density is not uniform, is not be uniform over the section, but somewhat higher at the surface. At some section this can be higher, at some section it can be lower. कहीं पे ये ज्यादा हो सकती है, कहीं पे ये कम हो सकती है. So this section can be, and this makes the AC resistance little more than to the DC resistance, जिसकी वजह से हमारा AC resistance कभी कभी ज्यादा भी हो सकता है, DC resistance से भी हमारा कम ज्यादा भी होता है. तो make in your mind that when we talk about the alternating current, so always a transmission line carry the alternating current. So in this section, we only talk about the AC current. So AC current makes produce the skin effect, and the skin effect what must create it create the current density is not uniform entire the section, so that the moreover in the standard conductor, the length of the each standard is more than the length of the composite conductor, thus increasing the value of the resistance from that calculated. So here this is the another section, that standard type conductor. So here I only considered the solid conductor. So solid conductor, there must be in create the, there must be produce the skin effect. So here this is only the calculation formula of the resistance, that is the R is equal L upon A. So here you can easily calculate the value of the resistance by putting the value of the L, by putting the value of the A, and by putting the value of the constant, that is the rho, that is the ohm meter. So this is the section. This section is describe you the resistance of the transmission line, resistance of the conductor, of resistance of any wire. So in the next section, we calculate the how we calculate the resistance, how we calculate the inductance of the transmission line. Thank you so much.